Today is 14th of April 2025. What we are talking about is gradient descent ideas again. We last time solved dataset with MLP and also Schiffer 10 dataset with CNN. We used Adam Optimizer, and we will talk about how Adam Optimizer and others really works. The gradient descent main algorithm, main important thing is learning rate and gradient size. Learning rate is related with current hot topics, which is find local minima, which is flat local minima or narrow local minima. We usually use this picture, but this is not a good picture because we usually use gradient descent for loss function, which is non-linear functions. If it is y equals x squares, we can just directly find it, or maybe we can also use interval bisection or secant or Newton's method or other method. So this gradient will be vector, and we'll also talk about why FGD is not really working on Plateau and Ravine, because FGD use mini batch, and in Pluto case it's a very Pluto. For Ravine case, theta 1 is moving plus 10 minus 10 plus 10 minus 10. Theta 2 is moving like plus 1 plus 1 plus 1 plus 1. Then which means if we using FGD, we will just move this, not going down the stream. So if we should think about how can we move this way. So we weight sum this case by this. This is what we call adaptive learning rate algorithm. No, this is what we call momentum algorithm. And for adaptive learning algorithm, what we want to use it in plateau situation, because we want to update what is not updated. So we want to go escape the plateau. What we are using is basically exponential moving average idea, which is ft equals to 1 minus r ft minus r plus r this. If we can define it, then we can define every component like this situation, and we will measure the size by GT and GT's inner product. Then we will use adaptive learning rate algorithm formula as this one, which is ft minus 1 plus 1 minus b this one. So if you phi inner part, then which is 1 over square root of ft, which means if it is more updated, we will not update it much. Thank you.